Howdy folks, so in this video I'd like to review where the integration by parts formula comes from. And so to do that, let's go ahead and let u of x and v of x be two differentiable functions. And then what I'd like to do is I'd like to go ahead and remind ourselves of the derivative of the product of these two functions. So I'm going to say d dx of the product of the two functions. And from our first semester of calculus, we learned that we could do this using the product rule. So we'd say that would be the first function times the derivative of the second function plus the second function, v sub x, times the derivative of the first. And what I'd like to do now is just as sort of a shortcut, as I'd like to write this in terms of prime notation. So I'm going to write this as uv prime is equal to uv prime plus vu prime. And now I'm going to take the antiderivative of both sides with respect to x. Now that I've done that, I'm getting close to what I want. I need to make two observations. The first one is that here I am taking the antiderivative of the derivative of the product of these two functions. So by the fundamental theorem of calculus, we just end up with the product of those two functions. So on the left-hand side, I'm just going to end up with the product of u and v. And we're not going to worry about the arbitrary constant here. We don't really we could be more careful with our derivation, but I just want to show you roughly how this is related to the product rule. So I'll just put uv there. And then on the right-hand side, I need to remind myself that the antiderivative operator distributes over sums of functions. So I could rewrite this as the antiderivative of uv prime dx plus the antiderivative of vu prime dx. So then what we're going to do is we're going to be a little bit sloppy here and with our notation, but this is just to show you where the formula comes from. And I'm going to write v prime of x dx. Well, that's equal to dv dx times dx. And being a little bit sloppy, we'll say, oh, let's cancel those differential operators. And so that just gives us dv. And the same thing here, we could rewrite this u prime dx as just du. And so rewriting this expression on the right-hand side, we've got uv is equal to the integral of u dv plus the integral of v du. And so if I were to go ahead and isolate the integral of u dv, and then doing a little bit of rearranging, we end up with the integration by parts formula. So this is our formula for doing integration by parts. And what it does is it gives us sort of a choice. If we have a complicated antiderivative on the left-hand side, what we could do is perhaps rewriting it as this problem on the right-hand side will be easier to integrate. And that's our hope. And the next few examples we'll review a little bit about how to decide which function you should pick in each case, and give you a few examples of problems which are made simpler by the integration by parts formula. Thanks for your patience, folks. I hope this was helpful.